Remember trying to talk to a voice bot just a few years ago? It often felt like uh, shouting into a tin can, right?
Yeah,
The clunky pauses, that really robotic monotone, the sheer frustration when it just didn't get you.
definitely.
Fast forward to today, and our expectations have completely rocketed. We don't just want basic interaction, we demand, fluid, natural conversations, almost like we're talking to another person.
It's true. Our brains are hardwired for human communication, and, well, that sets an incredibly high bar for machines. That
Exact.
leap from that frustrating tin can experience to truly seamless conversation, that's precisely what we're going to dive into today.
Absolutely. We're taking a deep dive into the fascinating world of real-time voice AI. We're exploring the cutting-edge tech that makes truly conversational agents possible.
Hmm.
And you've shared some incredible insights from a recent workshop you attended, featuring some brilliant minds from Google DeepMind and Daily, all focused on building real-time voice AI with an open-source framework called PipeCat.
Yeah, that's right. Our mission today is basically to unpack the core challenges of making AI talk like us, introduce you to this open source framework, PipeCat,
Yeah.
that's tackling these challenges head on,
Okay.
and reveal some of the, frankly, surprising innovations, making voice AI feel incredibly natural and crucially responsive.
Sounds great. Get ready for some serious aha moments, I think.
Hopeful.
Okay, let's unpack this. Because when you really think about creating a machine that can talk like a human, you quickly realize it's a monumental challenge.
It really is.
We've had, what, tens of thousands of years of evolution shaping how we communicate, so our expectations for machines are, understandably, sky high.
Exactly. As users, we basically come with three core demands. First, we want a good listener, something smart, conversational, and genuinely connected to relevant information.
Right, not just reciting facts.
Precisely. Second, it has to sound natural,
Hmm.
no more robotic voices. And on that note, big kudos to the Google team because their latest Gemini Live native audio dialogue, it's incredibly
This
natural.
really is.
You almost forget you're talking to an AI.
It's astonishing how far that's come. And beyond sounding good, it has to be lightning fast, right?
Yeah.
Because nothing kills a conversation like those awkward, long pauses.
Speed is totally non-negotiable. Think about it. A human conversation, the back and forth, it has an average turn-taking latency of around maybe 500 milliseconds.
Half a second. Wow.
Yeah. The industry benchmark for AI end-to-end communication is currently around 800 milliseconds, but we're always striving for that human level 500.
And getting there is tough.
Achieving that,
Yeah.
with all the complex processing involved, it's incredibly difficult. That speed requirement is a critical and constant challenge.
And that's precisely the mission for the team behind PipeCat, as I understand it. They're really dedicated to meeting these challenging expectations.
That's the goal.
So tell us, how exactly is PipeCat designed to meet such a challenging bar? What is it at its core?
Okay, so PipeCat is an open-source Python framework. It's specifically designed for building voice and AI multimodal agents.
Multimodal meaning more than just voice.
Yeah, potentially voice, video, text, other data streams. It's developed by the team at Daily, and while it's been an open source project for just over a year, it officially launched around March 2024, it's already making a huge impact.
Okay.
Its core purpose is really to simplify the inherently complex process of creating these real-time voice AI applications.
So it's not just one magical black box that does everything, is it?
Yes.
When we imagine a voice AI, we might think of a singular entity, but it sounds like it's actually a lot more intricate than that.
That's a great way to put it, yeah. Imagine voice AI not as one big box, but more like a series of specialized boxes or processors that data flows through, one after the other,
Okay.
each one performing a specific task. We call this a multimedia pipeline, often referred to as the cascaded model, because each step sort of cascades into the next.
Right, the cascade model.
Yeah.
Okay, so in that traditional model, what does that flow actually look like? Walk us through the steps.
Sure. It usually starts with transport. That receives your audio input, say your voice, in a meeting or a call.
Yeah.
That raw audio then goes to a speech-to-text service, an STT service. That transcribes it into raw text.
Makes sense.
That text then feeds into a large language model, the LLM. That processes the text and generates a response, usually in what we call tokens.
Tokens, right, little bits of language data.
Exactly.
Yeah.
Think of them as the LLM's internal language. Those tokens are then sent to a text-to-speech service, TTS, which converts them back into audio.
Okay, so text back to sound.
And finally, that audio goes back through transport to output the sound to you.
That sounds like a lot of handoffs, a lot of different pieces talking to each other. So PipeCat acts as the orchestration layer for this entire, sometimes kind of unwieldy pipeline.
Precisely. Yeah, orchestration is the perfect word. It provides that along with many common utilities you'd need, like recording audio, managing different outputs, manipulating information as it flows through.
Right.
But what's truly fascinating here, I mentioned Gemini Live, is how services like that are changing the game.
Yes.
Well, for them, this entire multi-step process is dramatically simplified because Gemini integrates the STT, the LLM, and the TTS all within one box, essentially.
Wow.
A unified model.
Wow, okay. That sounds like a huge leap in efficiency. So this isn't just about combining existing pieces better. We're talking about a real evolution towards these speech-to-speech models.
That's right.
What does that mean for how developers actually build these applications? Does it make things easier?
It's a fundamental shift. In the last year or so, we've seen the emergence of these speech-to-speech models that take raw audio input and directly produce raw audio output natively.
So no text step in the middle necessarily.
Exactly. They can optionally output text if you need it, maybe for logging or parsing information, but the core transformation is audio to audio. And yet this drastically simplifies the application code.
I bet.
Instead of needing that complex multi-component orchestration for each STT, LM, TTS step, you get a much more streamlined approach where the core AI handles a lot more of the heavy lifting internally.
But there's still a catch, right? Even with that simplification, you still need something to manage the rest of the application, the bits around the core AI.
Yes, absolutely. You definitely still need an orchestration framework like Pipecast. It handles all those essential surrounding elements.
Like what?
Things like connecting to the right audio source, managing interruptions gracefully, handling turn-taking, integrating external tools or APIs. Even if the core LLM handles the STT and TTS internally, Pipecast manages the whole conversation flow.
Okay, that makes sense. And this brings us to what you called Pipecast's true superpowers, its modularity and flexibility. This sounds really key for developers.
It really is.
You mentioned this plug-and-play modularity.
Yeah, it's incredibly powerful. Imagine building a complex system where you can just swap out different services like your STT provider or maybe a specific text-to-speech voice you like without having to rewrite your underlying application code.
That sounds amazing.
It is. You could use, say, DeepGram for STT, then maybe Google or OpenAI for the LLM, and Cartesia or Eleven Labs for TTS. You can mix and match as you wish.
Without rewriting the box core logic every time.
Exactly. It significantly cuts down development time and gives you incredible flexibility to optimize for cost or performance or specific features from different vendors.
That's a huge time saver and a massive agility boost for developers. And you mentioned it gets even more sophisticated with parallel pipelines.
Indeed. Pipecast allows for some really complex scenarios, what we call split branches, where different logic can run simultaneously within the same call.
Okay, like what kind of scenario?
Well, for example, you could set up a really robust failover system. Imagine if one vendor's STT service suddenly goes down mid-conversation.
Nightmare scenario.
Right. But with Pipecast, the system could dynamically switch to another vendor's STT service during the same conversation, seamlessly transferring the context.
And the user wouldn't even notice.
Hopefully not. The user would ideally never even know there was an issue behind the scenes. That's true resilience in production.
Wow. And this next feature you mentioned sounds like a fundamental shift for how developers interact with large language models. The universal function schema.
Yes, this one is truly a big deal. It simplifies things at a foundational level. One major headache for developers working with different LLMs
I can imagine.
is that they all have slightly different ways, different formats for defining and calling tools or functions. Like get weather or book appointment.
Right, proprietary formats.
Exactly. So Pipecast created a universal schema for defining these tools. This means you can write your native function definitions once in a standard way.
Okay.
And they'll work across different LLMs like OpenAI, Anthropic, Gemini, Bedrock, even Grok, without needing to transform the calls or write specific adapters for each one.
Hold on, that sounds huge. How much work does that save?
Think about the time developers previously spent writing boilerplate code just to translate these tool calls between different LLMs. It could be weeks of work for each new LLM integration. This universal schema collapses that into potentially just a few lines of configuration. It frees up engineers to focus on building innovative features instead of wrestling with compatibility headaches.
That's not just simplification. It's a massive acceleration for development, a genuine game changer.
Totally agree. And beyond that, it also has smart event handling built in.
Event handling, like what?
So the Pipecast transports the input-output parts. They emit events when clients connect or disconnect.
Ah, okay.
This allows the bot to initiate conversations automatically. For example, if you join a meeting where the bot is present, it can immediately say, "Hello, how can I help you?"
Mm,
without needing you to say something first.
that makes the interaction feel much more proactive and, well, natural.
Exactly. Less waiting around.
So if we were to sort of deconstruct a typical real-time voice bot, taking all these concepts into account, what are the key components as managed by Pipecast?
Okay, let's break it down. First, you have the transport. That's the mechanism for both audio input and output. Daily, being a WebRTC provider, is a common choice here, especially for web-based clients connecting to a server.
Right, the pipes in and out.
Then, for many basic LLMs, there's context aggregation. Imagine a bot forgetting what you said 2 sentences ago, incredibly frustrating.
The worst.
So this component is kind of the unsung hero preventing that. It collects every turn of the conversation, both what the user said and what the assistant replied, and formats it so the LLM can understand the full history, the context.
Crucial for coherence.
Absolutely. Though, interestingly, as we mentioned, services like Gemini Live often handle much of this context management internally now,
Right.
which simplifies the external architecture needed.
Okay, so transport, context aggregation,
Yep.
then the brain. Right, the LLM itself.
Exactly. That's the LLM service. Could be Gemini Multimodal Live, could be OpenAI's models, Anthropic's, whoever wrapped by Pipecast. And critically, you have tools. These are those predefined functions the LLM can call upon. Things like fetch the current weather or get a restaurant recommendation.
Thing that the AI can do.
Precisely. In the workshop demo, they even used dummy versions of these because of connectivity issues, but they showed the potential for real practical applications, booking flights, checking inventory, you name it.
Okay, and the last piece.
The system prompt. This is super important. It's the initial set of instructions you give the LLM that defines its role, its personality, its constraints.
Like you're a helpful assistant.
Exactly. Or you're a witty pirate who helps with travel planning, or you are a clinical intake bot. Be empathetic but concise. It sets the bot's entire persona and goals for the conversation.
Right, sets the stage. Okay, moving under the hood a bit.
Right.
Let's talk transport choices. You mentioned WebRTC. When would you use that versus, say, WebSockets?
Good question. So if you're building a client-server application, think a web app connecting to a bot running on a server. WebRTC is strongly emphasized.
Why is that?
It generally offers superior audio quality, it has better error correction built in for potentially choppy internet connections, and, crucially, lower latency. All vital for real-time conversation.
Okay. So WebRTC for browser to server usually.
Yeah.
What about WebSockets?
WebSockets are perfectly fine and often the most efficient option for server-to-server applications,
Like
like a phone chatbot service that needs to connect to a back-end phone provider, maybe like Twilio. Serve talking to server, WebSockets work great.
And Pipecast supports connecting to actual phone lines too, right? Not just internet calls.
Absolutely. It supports various ways to connect with phone carriers. You can use WebSocket connections to specific phone platforms. You can interface with the PSTN, that's the public switch telephone network, your traditional phone lines.
Old school copper.
Pretty much. And also SIP, Session Initiation Protocol, which is basically the standard for voice and video calls over the internet. Think of it like HTTP, but for real-time communication. So lots of flexibility there for different telephony needs.
Okay, great. Now let's talk about something incredibly crucial for making conversations feel natural. Voice activity detection, or VAD.
Oh yeah, VAD is vital.
It detects when a user starts speaking. Why is that specific moment so important?
It's truly essential for natural turn-taking. VAD allows the bot to interrupt itself if it's speaking and immediately hand the conversational turnover to the user the moment they start talking.
Ah, so the bot doesn't just steamroll the conversation?
Exactly. Without effective VAD, the bot would just keep talking or you'd have really awkward delays. For it to work well, VAD needs to be extremely accurate and, again, lightning fast.
Any recommendations there?
Solero, which is an open source option, is highly recommended. It performs really well and has incredibly low CPU consumption, like a fraction of 1%, which is amazing.
Wow.
And developers can also fine-tune it. You can adjust how long the VAD waits after hearing some speech before it definitively decides the user has started speaking. It's a balance between ultra-low latency and avoiding false triggers, ensuring a smooth, natural flow.
Balancing act. Okay, let's shift to the real cutting edge now. Latency, guardrails, context management. Latency is still a major hurdle, isn't it? Especially with the large context windows and LLMs.
It is. And specifically, this is where it gets really interesting and remains a critical challenge. tool calls.
The function calls.
Yeah. While streaming responses for just conversational output,
Yeah.
hearing the words being generated are now incredibly fast. Tool or function calls are still comparatively slow
Why is that?
because the LLM generally needs to receive the entire response from the tool, often formatted as JSON, before it can process that information and decide what to say or do next. That wait causes significant delays.
How significant?
Well, for example, OpenAI models have been observed taking maybe 1.5 to 2 seconds just to get the first token back after making a tool call, whereas Gemini Live, in some cases, can be much faster, often under 500 milliseconds for basic calls.
That difference, a second, second and a half, feels like an eternity in a real-time conversation.
It completely breaks the flow.
So how are developers tackling that? How do you keep the conversation flowing despite those potential delays from tool calls?
Several strategies. One is chunking prompts into smaller, more focused, task-oriented segments. This reduces the immediate processing load on the LLM.
Okay.
Also, actively managing the context window is key. This isn't just about remembering things, but also forgetting or summarizing things appropriately.
Forgetting.
Yeah, like summarizing parts of the conversation that are done, or even completely removing specific information once it's no longer relevant. For instance, in a patient intake bot, once you've verified the date of birth, you might remove that specific piece of PII from the active context being sent back to the LLM on subsequent turns.
Makes sense. Security and efficiency.
Exactly.
Okay.
And Google's Live API, notably, offers features like rolling or sliding context windows, which is a major advancement for managing this dynamically in conversational AI.
What about guardrails? Preventing the AI from making things up, hallucinating, or giving inaccurate information, especially when it has to respond instantly.
Yeah, that's a huge area of ongoing work. While it's not always a hard requirement for every single use case, dealing with potential hallucination and ensuring accuracy is a significant challenge in real time.
So what are the main strategies?
The core strategies really revolve around controlled prompting, giving the LLM very specific instructions and boundaries, and that careful context management we just talked about. Keeping the AI focused and truthful within the defined scope of its task and the information it has access to.
Right. Keeping it on track. Now, noisy environments. That sounds like voice AI's true kryptonite. Background noise like, chip bags crunching, dogs barking, even other people talking nearby. That must kill performance.
It absolutely does, yeah.
Yeah.
Imagine trying to have a critical conversation in a busy coffee shop. It's
Yeah.
tough even for us humans, right?
For sure.
It's even tougher for current AI. While VAD itself doesn't really handle noise cancellation, you can integrate external services directly into the audio input transport layer.
Services specifically for noise removal.
Exactly. Like Crisp, who are actually a PipeCat partner,
Huh.
they specialize in removing both ambient background noise and confusing background human speech, making the primary speaker incredibly clear before the audio even hits the STT service.
So you clean the audio before the AI tries to understand it.
Precisely. It's a vital piece of the puzzle for making these systems work reliably in real-world, messy environments.
Okay, finally, let's talk about maybe the biggest remaining annoyance with current voice AI, when the bot talks over you.
Ugh, yes.
It's so jarring, it completely breaks the feeling of a real conversation. You mentioned this is still largely an unsolved problem. What's being done to fix that?
It's a really fascinating and rapidly emerging field, often called semantic end-of-turn detection.
Semantic end of turn, meaning understanding the meaning of when someone's done.
Kinda, yeah. Instead of just relying on simple pauses or silence detection, which is easily fooled if someone just pauses to think, these new models are looking at deeper semantic cues.
Like what kind of cues?
Things like filler words, changes in pitch or intonation, the grammatical structure of the sentence, or even the overall context of the conversation, all to make a much more intelligent guess about whether a user is truly finished speaking or if they're just taking a natural pause.
Wow. That sounds complex but necessary.
It is. And PipeCat actually has its own experimental model for this called SmartTurn. It classifies the incoming user audio as likely complete or incomplete.
And how does that help?
Based on that classification, it can dynamically adjust the VAD timeout. So if it thinks the user is likely just pausing mid-thought, incomplete, it gives them a bit more time before assuming they're done. If it thinks they finished complete, it responds faster.
So it adapts the turn-taking timing based on understanding the conversation flow better.
Exactly. This promises a much, much more natural, human-like conversational flow. Finally tackling that annoying talk-over problem head-on. It's really the frontier right now.
It's just incredible to hear how much innovation is happening, moving beyond just understanding words to understanding conversational dynamics. And this tech isn't just theory, right? PipeCat is already out there, making a real-world impact.
Oh, absolutely. It's already being used in production by some very large companies, handling, I believe, hundreds of thousands of calls a day, so it's battle-tested.
And it's not just the daily team building it.
No, that's the beauty of open source.
Yeah.
There are active contributions from major players like NVIDIA, AWS, OpenAI, Google. They're all involved in the project.
That's serious backing.
Definitely.
Mm.
Plus, it's not just server-side code. PipeCat offers client SDKs, too, for Android, iOS, JavaScript, React, even C++.
Meaning developers can build these agents directly into apps or devices.
Exactly. Enabling these intelligent agents to run smoothly on various devices, from your phone to maybe even embedded systems in the future.
One of the most fascinating applications I heard about from the workshop was using evil bots. Bots that talk to each other to test services end to end. That sounds wild.
It's brilliant, isn't it? And incredibly practical. These evil bots can automatically run through test scripts, verify responses, check latency, ensure functionality across different software releases.
So automated QA testing using AI.
Pretty much. Imagine the time and resources that used to go into manually calling a bot thousands of times to check for regressions after deploying new code. Now these AI agents can do it tirelessly, 24/7. It makes the development cycle incredibly faster and more reliable.
It's like having an army of tireless QA testers working around the clock. Amazing.
It really is.
And for a cool interactive demo that people might be able to check out, there's Word Wrangler,
Ah, yes, Word Wrangler.
a game built with Gemini Live and PipeCat, where you describe a word and the AI tries to guess it. Really shows off the real-time responsiveness.
It does, and the phone-based version of Word Wrangler actually takes it even further, demonstrating PipeCat's really advanced orchestration capabilities.
How so?
That version uses two separate Gemini agents running in the same call within a parallel pipeline in PipeCat.
Two AIs in one call.
Yeah. One AI acts as the human's host. It gives the questions, guides the game. The other AI is the guesser, and it's configured within PipeCat to only hear the user's description, not the host AI.
Whoa, that's sophisticated routing.
It really demonstrates the kind of complex, unique, parallel interactions you can build with PipeCat's framework, things that would be incredibly hard to manage otherwise.
Very cool. And beyond just the voice, you mentioned PipeCat also allows for synchronized word-by-word text output alongside the audio?
Yes, from compatible TTS services like Cartesia or 11 Labs, they can provide timing information for each word.
And PipeCat handles that synchronization.
Right, so you can have the text appear on screen perfectly timed with the spoken audio. That's incredibly useful for visual clients. Think live transcription during a meeting, captions, enhancing accessibility.
Yeah, or just letting people scan the text quickly. It turns a purely voice interaction into more of a multimodal experience.
Exactly, richer user experience.
So wrapping this up, what does this all mean for you, the listener?
We've seen just how much goes into making real-time voice AI feel effortless. It's anything but simple behind the scenes. From shaving off every possible millisecond of latency to understanding the nuances of our natural pauses and conversational context, it's incredibly complex.
And that push towards things like semantic end of turn, these smarter models, it really suggests a future where our conversations with machines might become, well, virtually indistinguishable from talking to another human.
That's a pretty profound thought.
It is. And the rapid progress we're seeing, this dissolving barrier between human and AI voice interaction, it really raises an important question, doesn't it?
Which is?
If we can truly talk to machines as naturally as we talk to each other, what new forms of connection, assistance, maybe even companionship might emerge from that? How will this reshape our daily lives, our work, even our understanding of intelligence itself?
A lot to think about. What stands out to you the most from this deep dive into where conversational AI is heading? Something for you to mull over.